This video shows the steps in building a high-quality tungsten carbide tipped saw blade. Every saw starts with a blueprint showing all the dimensions and technical information needed to produce the steel body or plate. The print includes such items as the hook angle, tolerances for the thickness of the body, bore, diameter, and the shape of the teeth, and any other specifications that would affect the performance of the saw. Upon arrival of the plates from the plate supplier, all specifications are checked according to the drawing to ensure the quality of the finished product. The next raw material to be chosen is the tungsten carbide tip itself. The parameters for the proper selection of the tip include such factors as the cutting application that the saw will be used for and the material being cut. This information is needed in order to determine the proper grade or hardness of the carbide. The last raw material to be chosen is the silver solder, which should have a high silver content, about 50%, to ensure the best possible bond between the carbide tip and the saw body in the brazing process. Go. In torch brazing, the melting of the solder is done by the use The ratio of gas to oxygen must be correct, or it can cause oxidizing of the steel, turning the surface of the steel black, which can cause the solder not to flow properly, or not to flow at all, making a poor bond. The torch brazing in the hands of an experienced operator can result in high quality brazing and can be successfully used for replacing damaged or broken tips, or for small production runs of limited quantities. High-frequency brazing is accomplished by replacing the method of melting the solder using a high-frequency coil with electricity running through it instead of a torch. The preliminary steps, such as cutting the solder, the placing of the flux on the solder as well as on the tip, is usually also done on the machine. In machine brazing, usually every other tooth is brazed in order not to generate too much heat in one spot of the saw. Therefore, to completely braze a saw, it will make 2 revolutions on the brazing machine. Once the brazing is complete, the saws are checked for imperfections in the brazing after they are sandblasted by placing them under an illuminated magnifying glass. Once the brazing cycle is completed, the saws go to the hammering department, where the saws are checked for flatness and lumps in the body of the saw. Saw doctors, with over 30 years of combined experience, first initially check for flatness with a straight edge. The saw looks like it is within specifications. If it is not, he then hammers the blade to make necessary adjustments. The hammerman will put the saw on a run-out stand, which is equipped with a dial indicator. The operator will rotate the saw with the indicator pressing against one side of the saw to check for lumps and to establish a center point for the saw. Once this is done, he will reverse the saw and rotate it again against the dial indicator to once again check for lumps and to check the center point of the saw as compared to the first side. This tells him if the saw has a dish in it or if it is flat. If the dial indicator shows a dish, he will hammer the blade so that it is within a preset tolerance for the particular type of saw and its application. At this point, the saw is ready for grinding. All the grinding is done with CNC grinding machines that are specifically engineered and designed for the grinding of TCT saws. The grinding process itself is broken down into first, the grinding of the face of the teeth, second, the grinding of the sides of the teeth, and finally the grinding of the OD, or the top of the teeth. Let's take a look at each step and its importance in producing a high-quality TCT saw. The face grinding must be done first in order to ensure that the next and most important grinding operations will be true or uniform. We are now at the point that the saw is ready for side grinding. In side grinding, there are 3 different things that are checked depending on the type of saw and its application. First, the overhang or distance of the highest point of the tip from the body. Second, the tangential clearance, which is the angle from the face of the tooth to the back of the tooth. Third, the radial clearance, which is the angle from the outside diameter going toward the center. In side grinding, all of the above must be within the specifications for the particular type of saw being ground, or it will not perform to its optimum. The last grinding operation performed is the grinding of the outside diameter, or OD. Again, depending on the type of saw, the OD is ground on CNC machines using a particular program which is called up from the machine's memory. Concentricity is guaranteed by the rotating the saw's board during the grinding. Now that all the grinding has been finished, the saw goes to the polishing station, where the steel body is polished with the use of flood coolant in order to keep the saw cool, thus preventing any possibility of warping. In the final step, the saw goes to the shipping department for one last inspection and packaging. At this stage, we can now say that we have created a high-precision cutting instrument known to the woodworking industry as a high-quality TCT saw blade.